Hello, everyone.
Good afternoon, sir.
Hello, sir.
So we can start now, right?
Yes, sir.
Can you allow me to share the screen?
Oh, my bad. I'll just make you the co-host. Can you share now?
So I hope the screen is visible now. There were only 6 to 7 participants, I guess, in the last meeting because of the, I guess, Ganesh Chaturthi festival. But today, I hope more number of people will join. So let me say what we were doing in last two sessions. In first session, we talked about introduction to cloud and time. There are events in the past which have happened, and because of them, the cloud is emerged. In the last lecture, my major focus was on formal model of virtual machines and a typical cost calculation for a startup who wants to establish a website or a web server. Should it happen in-house or on cloud? This decision we were taking. And at the last of the previous session, we were talking about the Goldberg and Popek's paper. I hope everybody has received this paper. Yes. And some of you might have even had a chance to look at the paper, at least abstract, conclusion and introduction. क्या किसी ने देखा है उस पेपर को?
No, sir. I
Okay. Anybody who was there in the meeting last time and could see the paper once? No, I will not ask any questions. Don't worry. I just want to know how many actually saw the paper. Shell Patel, could you see the paper, Shell?
No, sir, I am yet to see it.
Okay, so there is nobody who saw the paper. So in that case, what we will do is we'll see the paper now here on the screen, right? So I was talking about two important aspects in the last session. One is 3 important properties of a virtual machine monitor. To be a virtual machine monitor, right? These 3 properties are needed: equivalence, efficiency, and resource control. When we talk about efficiency, equivalence, and resource control, one additional property comes up which says that this aspect: an architecture can be virtualized if sensitive instructions are a subset of privileged instructions. So to reiterate, there are 3 kinds of instructions on every computer. What are those 3 kinds? These: sensitive, innocuous, privileged. What do we mean by sensitive instructions? They change the system state, right? What are innocuous instructions? Regular instructions: addition, increment, right? In and out. What are privileged instructions? They can only be executed in kernel mode, right? You require superior permission to run these instructions. And Goldberg and Popek said that you require 3 properties. In addition to that, all your sensitive instructions should be part of privileged instruction, as should be a subset of P. S is sensitive and P is privileged. All S should be part of P. Okay, so this is the situation. In this case, one important aspect also comes up, that sensitive should be part of privileged. In this case, regular instructions can be directly run. Regular instructions can be directly run. So this is one very important point. When you are doing virtualization, when you are running more than one operating system on a single computer, and that computer is capable of running, let us say, 500 instructions, 500 different kinds of instructions, right? You all know that whatever programs we write in high level languages, they actually get converted into such instructions, right? So let me go to the board, because there are many who are new in today's lecture. Let me take some time to explain them what I want to say. So this is my hardware, and this is my VMM, and this is my VM1, VM2, and VM3. Now, what Goldberg and Popek said is that if you want to create a virtual machine monitor who can support virtual machines, it should be able to equivalence, efficiency, and third point is resource control. And in a relationship we require, let me stop this. Your S should be a subset of P. So we are saying that every computer has instructions which are regular, sensitive, and third one is privileged. Now what I want, that these regular instructions I have no problem. Every virtual machine can directly run these instructions on the hardware. VMM will not interfere. There is no problem, because regular instructions don't change the computer's state. Sensitive instruction should be subset of privileged. In this case, I want to look for every sensitive instruction, if it is privileged or not. I'll tell you the reason why we want this. We want that the whole control should be with this virtual machine monitor software, right? We want that it should be able to see these sensitive instructions, because they may change the state of the machine. One VM will know, one other VM will not be able to know if they are doing these things in isolation, right? Now, this relationship of sensitive and privilege also came from one important idea, which is known as idea of computer architecture. I hope each one of you have studied this subject, computer architecture, or somewhere there are names like computer architecture and organization, or there may be a separate subject on computer organization. So let me show you one architecture of processors, what kind of privilege architectures they follow. So please look at this diagram. Privilege rings in x86. Privilege rings. How many rings are there? There are 4 rings. Ring 0, ring 1, ring 2, and ring 3. What do we mean by these rings? See, in very layman term, I should tell you that ring 0 is the most privileged ring. If your process is running in ring 0 on a computer, it means it can run any instruction. Now you may ask a question, sir, these rings are available on every computer? Yes, these rings are available on a processor. So ring 0 is most privileged, ring 3 is least privileged. So what do? In the case of a Zen virtual machine monitor, you run hypervisor in ring 0, virtual machines in ring 1, ring 2 is unused, and all the applications which are running inside the guest operating systems, they run in ring 3. Now, how do you implement such rings? See, these rings are in hardware. So hardware or processor chip understands that if a program is running in ring 0, it can run all instructions. What are the instructions? I told you, every processor has an instruction set that is also known as ISA, capital ISA. So suppose a P4 processor has 500 types of instructions. Then all 500 types of instruction can be run in ring 0. On the other hand, in ring 1, you can run, let us say, 480 types of instructions. Ring 2, 450, and ring 3, you may be able to run 400 odd number of instructions, right? So this is how the classification is done. So most of the time when you are running as a root user, let us assume, when you are running as a root user, it doesn't mean that you are running in ring 0. When you are doing kernel mode thing as a root user, then you are running in ring 0. Yes. So these rings make this thing very interesting. Okay, let me draw these rings on the boards and tell you what happens with a normal operating system. So when you talk about a normal operating system, you may have these rings. Yeah. Ring 0, ring 1, 2, and 3. Remember, I told you that these processor manufacturing companies, they never manufactured processors by keeping virtualization in mind till 2007-8. Later they thought about it, but earlier they were not thinking about virtualization. So in ring 0, we used to run operating system, OS. Ring 1, we may run system software. Ring 2 and 3, mostly 3, we run applications. So in operating system, you all have studied user mode and kernel mode. Yes? User mode and kernel mode. क्या सुना है सबने user mode और kernel mode के बारे में?
Yes, sir.
Yes,
Okay.
sir.
So can anybody quickly tell me what is user mode and what is kernel mode, and why we require switch between them? Anybody? Just a brief would suffice.
So the user applications run in the user mode, and the core components of the operating system, they run in the kernel mode, which we cannot change.
Okay. So why do you require a switch between user mode to kernel mode? Do you require switch between user mode to kernel mode?
Mm.
See, you normally require switch between user mode to kernel mode. See, user mode and kernel mode are nothing but programs. They are loaded into main memory. There are certain programs which are, which comprise of important, portions of the operating system, like system calls, like file management, IO management, memory management, right? Or changing some kernel data structures. Those code are known as kernel codes. And whenever you want to do something which requires system privilege, you go into kernel mode and come back. So let us say printf. सबने सीखा कोड लिखा है printf, scanf, right? These are user mode calls, but ultimately behind the curtain, when you do printf, it actually get converted into write. Printf gets converted into write, and write is a system call. So when you do printf, you are actually switching from user mode to kernel mode, right? When you are doing scanf, you are actually doing reading. It's a read system call. So again, you are moving from user mode to kernel mode, and this is basically is known as context switch. Yes.
Yes.
Right? So context switch may happen when you switch from one process to another process, but when you go from user mode to kernel mode, then also this switching is happening. And this context switch is a cost. Remember, this is an overhead, but we need to deal with it because we cannot run all the system exercises in the user mode. तो अगर उस दिन के ऑपरेटिंग सिस्टम के कंसेप्ट को आज समझें तो ये रिंग लेवल से बहुत अच्छे से समझ में आएगा. That you are running in ring 3, ring 2, and you want to go and run in ring 0. Ring 0 is your operating system kernel, most privileged. So that can be done, and again you come back to ring 3. Yes. So it means whatever discussion I have right now, it appears to all of us that it means that the most privileged is ring 0, right? Ring 0 is most privileged, and we need to run the most important component here. Components which are not that important, they can run in other rings. So this theorem of Goldberg and Popek is pretty important, that all these sensitive instructions which are there, they should be privileged. So it means you want to run a sensitive instruction, it should always go and run in ring 0. Right? Now the question is, suppose there are sensitive instructions which are not privileged. Because in Intel x86 architecture, there are certain sensitive instructions which are not privileged. Why? Because they never thought about running multiple operating systems. There are sensitive instructions which are not privileged. You can run in them in outer rings, but there is no problem because there is a single operating system. It can keep track of everything. But now we have multiple operating systems here in ring 1, and here in ring 0, we are running operating system manager or virtual machine monitor. So this is the problem with the Intel x86 processor. They cannot follow Goldberg and Popek guideline completely. Right? So they were also worried, okay, what will happen? Cloud came, they are talking about the virtualization guideline. What should we do with such instructions? Any idea what can be done? What should we do? So let me tell you a little in detail. I remember that there are around 450 instructions in Intel x86 architecture, out of which there are 17 instructions, 17, which do not follow this relationship of as subset of P. Baki follow karte hain. There are 17 instructions which do not follow. What do we do with such 17 instructions? Any idea? क्या करें उन 17 instructions का?
Maybe they can have special access, like which others don't have, or maybe we can classify them as a different class of instruction.
No, but what will happen if there are 5 VMs and one of the VM runs those instructions and make changes, and VMM will not be aware about them, and but those changes have happened.
Mm.
Logs regarding that changes should be saved and then proceed to other VMware also.
Can you repeat again?
Logs regarding that changes that occurs due to sensitive instructions should be saved and then passes to other VMware so that they can also figure out what's happening in that virtual environment, virtual machine.
Okay. Any other suggestion by anybody else? Okay. See, I like the idea which is given by Kandar that you can run those instructions, keep some data, metadata logs that what has happened, and then you make aware other VMs that this thing has happened due to those instructions, which are not part of the the relationship which we are discussing, right? So please keep this in mind. Soon we will discuss about such methods. Let me give you some initial idea what we can do. First idea is, can I modify the operating systems which run on top of virtual machines so that they do not run those kind of 17 instructions? Let us modify the operating systems कि वो वाले 17 इंस्ट्रक्शन वो जनरेट ही ना करे. What do you think? This proposition is good or you don't find it interesting?
Sir, I mean, those 17 instructions might be important, so we cannot like just shut them off.
Yes, this one is one problem. Suppose that problem is not there. I have other means to implement those instructions. Then would you agree with my proposition?
No, no,
Yes,
sir. In
probably.
future, no, sir. In future, there can be possibilities that there is some instruction that are similar to that, but they are not in sensitive case, sensitive instruction set. Then the OS will also means we can't change OS after when we install. Firstly, in any laptop, so it's like we have just made a static viewpoint for OS that you just follow this rule and don't follow this rule.
No, we can change the code of the operating system. We can reinstall the kernel. We can.
Okay. In the sense that then we can do.
There is no issue in doing that, right? And once you do the modification, the operating system will not run those instructions because they have been specifically told that don't run those instructions. Yes. Okay. Other proposition let me give that we cannot avoid running those 17 instructions. We need them. Like one of you said that I may need those instructions, and I told you that will not run, but let me agree with you that we may need them. So what I'll do, I'll run those instructions not on the hardware. I will kind of simulate them, which is actually known as emulation. I will emulate them and show that they are running. Actually, they are not running. I'll run them in emulated environment and give you the result as the result comes from the natural environment. You will feel, the VM will feel कि भाई ये result आया है, सही है. But I'm not doing it on hardware. And everything I'll do, which will happen on the hardware, but in the form of simulation environment. So your instructions will also run. Sensitive and privileged relationship will also not be breached, and everything will happen in the software, not on the hardware. What do you think? This is a good proposition?
Yes, sir, I agree.
क्या ठीक रहेगा? And one more thing, because this question is not coming in your mind. Suppose there are 5 VMs and one of the VM is running those kind of instructions. I will simulate it and give you the result. Other VMs, if they do similar kinds of instructions, I will also simulate for them And I'll keep track that each one of them should feel that they are able to run all the instructions on the hardware. भाई किसी को जताना है emulation करके क्या फर्क पड़ता है? Suppose suppose the instruction is of this kind. Let me give you a better example. Suppose the instruction is POPF. POPF. What do we mean by POPF? Pop flag. Pop flag. Now, when you do flag popping, suppose there is a flag and whose value is, let us say flag is any flag, specific overflow flag, and its value is 1. If you pop it, it becomes 0. Yes. And suppose this is a sensitive instruction, but it is not privileged. Pop flag is sensitive but not privileged. What I'll do? I'll simulate this overflow flag in software. I'll make 5 copies of it. Overflow flag. 1, 2, 3, 4, and 5. Each copy belongs to one of the VM. VM1, VM2, VM3, VM4, and VM5. Now these are in software. They can be taken as a simple binary data structure in a C program. Yes, and every VM is popping or pushing this flag. There is no problem. They are getting the similar result as they could have received when they were running it on the real flag. But these are simulated flags. मैं ध्यान भी रख पा रहा हूँ, सब जने सारी VMs काम कर पा रही हैं, and I'm happy about it. What do you think? This would work?
Yes,
So
sir.
one thing was avoiding those instructions. Second thing was not avoiding, but implementing them in software. Yes, this can be done. Any other solution you have in your mind?
Sir, but if this is just a simulation and there is no impact on the like in real life, so how would that matter if it executes them or just lets them go?
Your voice is not very clear, Shell. Can you repeat and speak slowly?
Yeah, so if this is just a simulation, right? There is no
Yes.
impact on either things. So
Yes.
how does it matter that we let them run or we just discard them?
Okay. See, the importance of running them in simulated environment or a software environment is, see, VM is, when operating system is not modified, VM will surely run these instructions. And when they run these instructions, I, as a virtualization manager, is making sure that they are doing everything naturally. They don't feel that they are running on a virtualized environment. The results are same as they would have got when they are running as a single operating system. And my purpose of following Goldberg and Popek's guidelines fulfills. ये जो चारों requirement है मैं fulfill कर पा रहा हूँ बिना hardware को change किए.
Okay.
So it matters. It matters a lot, right?
Yeah.
Otherwise, the processor chip has already been manufactured, right? The
Yeah.
hardware chip cannot be changed. So today, let us say today somebody talks about, we are talking about 5G mobiles, right? So there are people who always think that when 6G will come, why would we need to change the hardware? Can we run 6G technologies on 5G device? Similarly, see, that may be possible, that may not be possible. Similarly, in 2007-8, people thought about it, that there are so many computers out there, so many servers are there, and we are thinking about replacing them. People would not agree. They are already worried about utilization. I told you about Gartner survey, right?
Yeah.
They were already complaining कि 25% utilization है, आपने हमें इतने बड़े सर्वर बेच दिए, अब आप कह रहे हैं कि इस पे virtualization नहीं चलेगा, नया सर्वर खरीदना पड़ेगा. So in both the cases, they are ruining their money, right?
Yeah.
Then people think about these solutions which may look because there are problems with these solutions, but they work. They follow the guidelines. Okay.
Okay.
Anybody else who has concern with this? Because I told you that there are problems with this solution. What may be a problem with this solution? Think about it.
Sir, in the solution, you had said that some VMware will execute only some of them, out of them, only one or two VMware will execute their sensitive instruction. Another will feel like that they are also uh, known to what's happening in the VM system. So if any calls happen in another VMware, like any other.
Why are you using the term VMware? You
Sorry,
should
I
just say
just I
VM. VM.
yes, sir. Sorry,
Yeah,
sorry,
yeah,
sir, for that.
yeah. Go ahead. Go ahead.
Yeah. So when VM1 who doesn't have capability of running sensitive instruction, if it hit by an sensitive instruction, he knows that this instruction is also run by other VMware, so he can also it can also run that instruction. So they create an issue that VM1 doesn't have capability of running that sensitive instruction. Still, the sensitive instruction hit that VM1.
No, but what is the problem? Because everybody got their independent flag, right? You do whatever you want to do with this flag, right? Because this POPF works with flag only. And this is a sensitive instruction, but not privileged. In reality, POPF is a sensitive, but not a privileged instruction. I have 5 copies of it. And real flag, I'm not modifying it. That can only be modified by VMM, which is the main operating system. Other guests have their copies and they are changing it and working with that, right? So it won't create a problem.
So will this all of this be dependent on one another? Like if there is a change in one, will it affect the other, or they are just independent topics? Because if they are dependent, then if one fails, then
This is important question. So there might be certain, things where we want to maintain the causality, dependency, right? In that case, what we'll do, I'll serialize those transactions. I'll serialize those events as a VMM, right? That I can do. And when they are independent, I can give them copies of each other.
right.
Yes. So that can be done.
Okay.
Now, the major problem with this proposition, let me ask you a fundamental question and please carefully answer this. I have a 32-bit addition, okay? And that addition I implement as a hardware chip or as a software code running on a separate hardware chip. आ रही है मेरी बात समझ में? 32-bit addition, 32-bit adder in terms of a chip. The option 2 is the same addition is implemented in software and run on a processor as high-level language code. Which one will be faster?
The hardware chip.
Hardware one, yes.
Hardware one. Why?
Because it is directly being run on the chip itself or hardware itself, so that the registers are much more faster than other types of.
Okay, but on this option 2 also we are running it on hardware, just the code is there.
But sir, there would be an overhead of switching from high level to low level, like from user mode to kernel mode.
Anybody else? See, the most important part is every software actually runs on hardware. Everybody knows about it. But I have a specialized hardware which is meant for addition. Right? So it primarily has pins which take input and gives you output over pins. On the other hand, the second option, there is a processor, there is a general purpose processor who have a lot of instructions. That might be a 32-bit addition available, right? Which I can directly do. But otherwise, there might be 16-bit addition, 8-bit addition. Then I need to create a 32-bit addition out of 8-bit adders, and it will take time. And software implementation generally is quite, time consuming as compared to hardware implementation. Yes. So directly running on hardware is beautiful. It's very quick, and we should always, try to do that. Remember, in one of the last slide, I told you that all the regular instructions can directly run. This diagram is there. All the regular instructions can directly run on hardware. Just the problem is with the sensitive and privileged. So with the sensitive, we are doing this, but this is a software implementation. This has to be very, very slow. This is pretty slow. Yes. So we can follow these guidelines. With this fourth guideline, we are okay with this, but the problem is speed. Speed will be slow because there is a software simulated implementation. ठीक है क्या? यहाँ पर मैं इस discussion को रोकता हूँ. We are going to come to this discussion very soon once we complete one more topic. But remember that I have two options. One is don't run those instructions. Second is implement them in software. Right? They both have their positives and negatives. We discuss them in a depth. We'll come back to them again. Right? This ring architecture we have discussed. Those of you who could not read the paper, I think none of you read the paper, which I, do not want. Whenever there is a reading material given, you should all read, and you should see the, quality learning in the next class, because once you read that, you get better motivated, better prepared to grasp more concepts. In any case, you have not done that. So let me go to that paper once and show you what has happened in that. So this was the paper. Formal requirements for virtualizable third generation architectures. Popek from California, Los Angeles. And this is Harvard plus Honeywell. So you all know that these are both the two universities which are there, right? Still today, they are the top ones. Okay, what they are saying, let us read the abstract. This is a very small abstract. We just need to read this much. Please, all of you should read. I'm also reading it. Virtual, I hope this is visible. Should I make it a little larger? Or it is visible?
No, sir, it's visible. Okay.
So virtual machine systems have been implemented on a limited number of third generation computer systems. I'm talking about 1974. For example, CP67 on the IBM 360/67. So there is a machine known as IBM 360/67, and there is an operating system CP67. From previous empirical studies, it is known that certain third generation computer systems, for example, DEC PDP-10, this is another name of the computer, DEC PDP-10, cannot support a virtual machine system. In this paper, model of a third generation like computer system is developed. Formal techniques are used to derive precise sufficient conditions to test whether such an architecture can support virtual machines. So the last line is very important and also tells us the importance of formal precise language for computer science graduates. Let me repeat the last line once again. Formal techniques are used to derive precise sufficient conditions to test whether such an architecture can support virtual machines. So सार की बात ये है, third generation computer can they support running virtual machines? For that, they prepare precise and sufficient conditions. So this is the beauty of mathematics. You need to be precise as well as those should be sufficient. We should not have any requirement outside that. So they are doing it very well. Remember, this was published in Communications of the ACM. You can see the name here. This is one of the topmost forefront journal talking about visionary technical ideas. Till today, people read Communications of the ACM to see what is going to happen in the technology world and what is the latest findings in technology world. So I have also given one copy of this paper which is highlighted. I don't remember because this one is not highlighted, but I have given you highlighted copy. So let me quickly do some of the portions. A virtual machine is taken to be an efficient, isolated duplicate of the real machine. Efficient, isolated duplicate of the real machine. We explain these notions through the idea of a virtual machine monitor. See figure 1. This is the figure 1 we already saw. This is a handmade figure they created. Hardware, virtual machine monitor, and VM is running on top of it. Yes. And this is very precisely written material. Please read that and appreciate the kind of, because see, whatever technology we are using today is based upon the papers like this, right? So I will not go into the notions which are there. I'll go to the requirements which are here. So let me do this. I can do it. Yeah. So the 3 requirements which we saw are written here. The second characteristic is efficiency. The third characteristic is resource control. And the first characteristics, which is equivalence, is here essentially identical. Right? So all 3 requirements are written here. First, the VMM provides an environment for programs which is essentially identical with the original machine. Second, programs run in this environment show at worst only minor decreases in speed. And third one is VMM is in complete control of system resources. Okay? These are the 3 properties: equivalence, efficiency, and resource control. Okay. This is simple set theory to understand what are the kind of instructions we have and what do we do with them. So you may want to read them, but let me come to what I want to show you. Yeah, this one. The virtual machine property. Yes, this theorem we studied. For any conventional 3rd generation computer, a virtual machine monitor may be constructed if the set of sensitive instructions for that computer is a subset of the set of privileged instructions. I hope this is visible to you. This is the theorem 1 I'm talking about. Right? This theorem is discussed. We have seen most of it, right, in our discussion. So you don't need to worry about it. But if you would have read it earlier, it would have made little more sense. So this is the relationship between sensitive instructions, right? Okay. The second part of this paper is on recursive virtualization. So let me talk about it a bit. See, so you are all running virtual machines, right? So what will happen if you do this thing? Let me draw a diagram. This diagram is already there. Hardware, VMM, VM1, VM2, and VM3. Now I do one interesting thing. I install a VMM software here inside a VMM. Can I do it? Installing a VMM software inside a VM.
I think yes.
Should be possible.
Should be possible. What may be the advantage? Why would you want to do it?
Maybe to check whether the virtual machine will crash. The first software will crash or not.
Okay. why the crash should happen? Why do you think there should be a crash? If there are ample amount of resources, why should there be a crash? No? Anybody else?
So maybe the rules governing each of them are different. What one might consider as important, another might reject them. So if we try to convolute them, then there may be such overlaps which can cause a machine to fail.
See, you can run more than one operating systems on a computer without doing this new thing, which we call recursive virtualization, right? That is not needed. So virtualization inside virtualization, right? And we continuously keep on doing it, right? It's not about the running virtual machine monitor, but we are doing virtualization at multiple levels. We'll come to it very soon. But this one, you may specifically want to do it for many purposes, including the purpose of, sandboxing. Sandboxing, right? So you want to apply limits on a program, you want to monitor it, control it, right? That you may want to do. You may also want to do it for purposes of testing, right? So malware analysis, testing, and even you may want to use it for attack. See, I should tell you that on every machine you have an NIC card. How many MAC addresses do you have? We all know about MAC address, right?
One unique MAC address is
One
assigned.
unique MAC address. And when you create virtual machines and you on top of them you run guest operating systems, they all get IP address.
Yes, sir.
They have MAC address. Do they have MAC address? Those,
No, sir. No, sir. Because the device is the same, no? How, if I'm wrong, then
Anybody else?
I guess MAC addresses are manufacturer assigned, but I don't know if one MAC address could be divided further like that.
Okay, so ideally what should happen? There should be only one MAC address on a single machine. Why would people come and run virtual machines if there is only a single MAC address? Because mostly IP addresses are mapped to MAC addresses, right? And if there is a single MAC address, how would you create multiple IP addresses? And what will be the point of running multiple web servers on a single hardware? People would not come and run their web servers on your cloud platforms if you only have a single MAC address. Does it make sense?
Yes, sir.
So what should ideally be happening, right? There should be multiple MAC addresses. So let me clear certain doubts. There is a unique MAC address of your NIC card. Okay, but MAC addresses can be changed. First thing, it can be changed. There can be multiple MAC addresses which you want to have on your machine. You show them to your network कि मेरे पास इतने सारे MAC address हैं, या मैं ये MAC address वाला हूँ, या अब मेरा MAC address बदल गया. हर 1 मिनट बाद, हर 2 सेकंड बाद भी अपना MAC address बदल सकते हो. It is like if I want to send a letter through post office, I can write any name in from. क्या लिख सकता हूँ या नहीं लिख सकता हूँ? I am writing a letter to, let us say, Kirtan. In the to address, I wrote Kirtan. In from address, I am writing Bill Gates. Can I write it?
Yes, sir.
Yes.
Okay. Would post office wala ask me for my Aadhaar card that you are Bill Gates or not? No, they will not ask. I can also put it in LAR dabba, right? And it will go. Similarly, the source MAC address, you can write anything. Though your device has a unique MAC address, but it doesn't mean that you cannot use any other MAC address. You can use it. So there is a very famous attack known as MAC spoofing. You have a great advantage of learning from a teacher who doesn't work in network security because it is quite aligned. So I can do MAC spoofing. My machine, I can write a script. I change my MAC address every minute. And I send through new MAC address. Because remember, on a single physical server, we are talking about having maximum 500 virtual machines. How many? 500. You may have multiple NIC cards, 4, 5, 10. You cannot have 500 NIC cards. It means you only have 5, 10 MAC addresses, which are physical MAC addresses. Most of others are virtual MAC addresses, which you can generate. And we do it every day. Look at your VirtualBox, Gen, VMware. Once again, they are creating a new MAC address for every VM and then assigning IP address and then sending the traffic. तो ये जो मैं कर रहा हूँ ना VM के अंदर VM, I may want to launch attacks, lot of MAC addresses, and remove the VM. After that, there is nothing there, right? So recursive virtualization is one thing. We went little off track, but remember, you cleared one doubt that MAC spoofing or MAC change is possible. You can have multiple MAC addresses on a single machine. Second thing is you can have multiple IP addresses on a single NIC card. I am again repeating it. Can we have multiple IP addresses on a single NIC card? The answer is yes. Those of you who want to try it, try. Those of you who want to know, एक बार try कर लो, फिर मुझसे पूछना अगर तुमसे नहीं होता है. Yes? Okay, so let us move ahead. Recursive virtualization has one important theorem. Let me go back to that theorem. The theorem is this. And theorem is yes. Please go ahead.
So if we can change our MAC addresses like that, but MAC addresses are kind of supposed to be unique. So how do we know that which MAC addresses are available to use, and what if two different entities are using the same MAC address?
Yeah. Okay, so you continuously change MAC addresses. There is no problem. If there are two MAC addresses which are on the same network, same network का मतलब हो गया. Right now, my laptop is connected to a network in our computer lab. Computer lab has 48 computers connected to a single switch, including my laptop. अगर हम 48 में से 48 में से अगर दो MAC SAM हैं, तो the switch will identify and will say there is a MAC spoofing, right? And if the switch is intelligent, it may stop one of the port, either me or that person. दोनों में से किसी एक को बंद कर सकता है. Otherwise, there is no point of having, different MACs in internet-wide communication, right? अभी तुम्हारा और मेरा MAC सेम होगा, तब भी कोई खास फर्क नहीं पड़ेगा. तुम अहमदाबाद में बैठे हो, मैं यहाँ पर हूँ अजमेर में, right? MAC's validity is in a local network, right? Do I make some sense, or you want little detailed answer?
No, sir. That cleared it.
Okay, so when I'm talking to you, actually, I'm changing my addresses quite often, right? So I have a MAC address. Suppose my MAC address is A, your MAC address is also A, completely same. But you are in a network, let us say you are in the campus of Ahmedabad University, then your lab setup is there. You have a MAC address. You got an IP address from Ahmedabad University. I also got an IP address from Central University. We both are talking to each other. Even we are not using our real IP addresses. We are using our public IP address in talking to each other. Yes. So Ahmedabad University might have a public IP address. Central University has a public IP address. Both the IP addresses are talking to each other, and our addresses are getting converted. Do I make some sense? Because if you want little detailed discussion, it requires a different class, right? It is known as network address translation. तुम चाहो तो अपनी कॉपी में लिख सकते हो network address translation, which works. But MAC uniqueness is okay. It is there. Uniqueness is there, but it is not required. The uniqueness is only checked in a single network, single local area network. ठीक है क्या? क्या मेरी आवाज आ रही है?
Yes, sir. Yes, sir.
Okay. Let us talk about recursive virtualization. A conventional third generation computer is recursively virtualizable if it is virtualizable. Virtualizable मतलब वो तीनों condition plus S subset of P. And a VMM without any timing dependencies can be constructed for it. Let me repeat the second statement. A VMM without any timing dependencies can be constructed for it. Now, what is this? What is timing dependency? So let me talk about timing dependency with the help of the board. This is our diagram. VMM. Let me choose a different color pen. So here is VMM. Here is VM1 hardware. Suppose VM1 got a chance to run on hardware and it runs for 5 seconds. How many seconds? 5 seconds. And it was preempted. Preempted means it was stopped to run. कि भाई दूसरों का number है, you stop. VM2 comes up. It ran for 5 seconds. After that, it was stopped. VM1 was stopped. Now VM2 is running and it is running for 2 seconds. I'm just taking an hypothetical example. This is slightly different, but we are doing it for understanding purpose. 2 seconds. Then it is also preempted, and again VM3 runs for 5 seconds. Again VM1 runs for 1 second, and it goes on. Now the question is, each one of them have their own clock. Yes, सबके पास अपनी घड़ी है. And there is a hardware clock running on the physical server. How do they make sure that they are running according to the hardware clock? Because they are run, then they are stopped, they are preempted, they again come back. So it is about virtual time and real time. So if you do recursive virtualization, these VMs are there. Again, on side there is a VMM who keeps a track. और उस VMM के ऊपर भी कई सारी virtual machine चल रही हैं. 1, 2, 3. वहां पर टाइमिंग और संभालना बड़ा मुश्किल होगा. Just because VMM is itself running inside a VM that is getting time. Let us say that it is getting 5 seconds. That is again divided among them. So we need to maintain multiple clocks. If we are able to do that, then we can do recursive virtualization. So there are 2 parameters. First, virtualization. Second one is timing. If both the conditions are true, we can do this. So most of the virtual machine monitors today follow recursive virtualization. You can do it. There is no problem. You need to give enough resources to virtual machine 3. Right? This VM3 should have enough resources to run a virtual machine monitor. So let me talk about what are enough resources. Suppose I have a 28 core machine. Then I should give 8 cores to each of the VM, and one of the VM who has 8 core and 32 GB of RAM. So the total is, let us say, 128 GB RAM available. So then I can give you 32 GB RAM to each VM, and then I can run 2-3 VMs inside that. So you require enough resources. If you have a small setup, a laptop with good configuration, then you can also create a VM, and inside that VM you can install virtual machine monitor and install small VMs, Tiny Linux or Pendrive Linux or Ubuntu with server edition, right? Small VMs can be installed. So this was the second point of recursive virtualization. If you want more details, please read this paper and describe what we have discussed, right? Then the last topic, which we already discussed, but let me discuss from this paper. As remarked earlier, there exist very few third generation architectures which are virtualizable. For that reason, We relax the definition to yield a related, more general but less efficient form, which we label as hybrid virtual machine system. मैंने कहा था ना अभी थोड़ी देर पहले कि मैं सॉफ्टवेयर में रन करूं तो जो 17 इंस्ट्रक्शंस बचे हैं उनको सॉफ्टवेयर में रन करूं, वही बात यहाँ पर है. Its structure is almost identical to a virtual machine system, but more instructions are interpreted rather than being directly executed. Interpreted means implemented in software rather than being directly executed. This they call is hybrid virtual machine system. This is less efficient, right? Hence, the HVM is less efficient than a VM, but as a result, more actual third generation architectures qualify. ज्यादा प्रोसेसर्स को क्वालिफाई करना है कि इन पे वर्चुअलाइजेशन चल सकता है, इसलिए ये इन्होंने रिलैक्स किया है. For example, the PDP-10 can host a HVM monitor. HVM is hybrid virtual machine. यहाँ पर interpretation होता है, although it cannot host a pure VM monitor, right? So this was the paper. कितने साल पुराना है ये? 48 years पुराना है, but still it has a great value, right? Please read this in order to have a comprehension of the papers. You are reading a very quality paper, right? Remember, this whole paper does not have any experiments, just mathematical notion, right? But see, it has large number of citations, right? So I'm closing this paper. Close current tape. Okay. Now let me also talk about another paper which is there in the folder. It is known as Above the Clouds, a Berkeley view of cloud computing, right? So I hope you can see this paper. I should tell you that there is a guy known as David A. Peterson. Both Professor Chaudhary and I have had a chance to meet him. He was a Turing awardee. I hope you know Alan Turing Award. Yes, Turing Award के बारे में सुना है?
Yes, sir.
Yes, sir.
Yeah. So David got a Turing Award. David is a big name in computer systems and computer hardware, cloud, right? So this they wrote in 2009, right? And as always, you see Berkeley is a top institution, right? It may be 2009, but it is a pretty valid paper today. ये mostly theory English story जैसा है, but हमने को पढ़ना है. You will get a great idea about what cloud is and how people think about it, right? So I'll go with only one paragraph from this paper. I recommend each one of you to see this paper, and if time permits, we'll go into detail of this paper. Okay. And they are very critical. They write everything very nicely. So whether we should go on cloud or not, let me go into this. Yeah, this equation you can see. Whether we should go on cloud or not, we should follow this equation. Can you read this equation? Let me say, user hours on cloud into revenue minus cost of the cloud. User hours on the cloud, उससे जो फायदा हुआ उसमें से कॉस्ट निकाल ली, दोनों को मल्टीप्लाई किया, एक वैल्यू आएगी. On the other hand, user hours in data center into revenue, same चीज है यहाँ पर भी, cost of the data center and utilization. Yes, if this equation holds, तो क्लाउड पर जाना चाहिए. अगर ये इक्वेशन होल्ड नहीं कर रही है आपकी एप्लीकेशंस के लिए, तो क्लाउड पर नहीं जाना चाहिए. This is a very important definition. What do we mean by data center? On data center, खुद से जो इंफ्रास्ट्रक्चर बनाया हुआ है. So we should only go on cloud if our revenue and cost, or pure revenue after subtracting the cost, is higher than manufacturing or devising or deploying the cloud on place or data center, right? This is one question. Also, many of the aspects which we are discussing, you will get wholesome idea from this paper. This is a very nice reading. Many issues. Because in 2009, if they were able to think this, I really think that these gentlemen who wrote this paper are extraordinary, and they are extraordinary. Few names you may want to see. One is Randy Katz, a very big name in systems, computer systems, operating systems, right? David is already there. Matej Jaharia, Ian Stoica. I think Ian Stoica is the top in cloud, and the most cited author among all the authors in the world, right? So this is just a brief introduction to this paper. This paper is there, Kirtan. You may want to share this with everybody, right?
Okay, sir.
Yeah. And if it is not there, please let me know quickly, right? After this lecture, I'll share this.
Okay, sir.
Let me go back to the slides. Okay. Now, we are going to the next stage, that let us understand how each individual resource can be virtualized. This will help us in actually seeing practically how do virtualization happen for every resource, and how does it differ from one resource to another resource. Okay, so the first resource and the most important costly resource is CPU, then memory, IO devices, network drivers, network devices, all such things are important. So let me go to the first thing, CPU. Let us read it quickly. Virtual machine monitor runs in privileged mode. We already seen the ring model, ring architecture, ring 0, virtual machine monitor. Guest OS and applications run in non-privileged mode. VMM time slices between different VMs similar to process time slicing, right? On a single operating system, we time slice between processes. थोड़ा time सबको देते हैं. Here, VM will time slice between or among multiple VMs. Once you switch from one VM to another VM, what will happen? Whole virtual machine state preserved on switching. Need to trap sensitive instructions. Why? Because sensitive should be part of privileged. In certain cases, we will write them in software simulation. अभी थोड़ी देर पहले हमने पेपर में भी देखा था, उसको उन्होंने कहा है interpretation. I told you about software simulation. The same name can be used for interpretation. Third name, which is used by many companies, including VMware, they call it dynamic binary translation. Dynamic binary translation. On the go, binary means executable. Translation means converting from one form to another. Dynamic binary translation. It means patching sensitive instructions to trap into the VM. Yes. And hypervisor, like an operating system allows system calls, hypervisor allows hyper calls. Hyper calls are nothing but system calls for virtual machines. Okay. This happens when you do processor virtualization. Let me go on some additional aspect. I'll come to it as fundamental explanation I'll give you. What will happen to interrupts? Earlier there was a single operating system. Now there are multiple operating systems. One operating system is host operating system. Other operating systems are guest operating systems. What will happen with them? Okay. So interrupts are managed by virtual machine monitor. Guest operating system disables interrupts. Guest operating system may interrupt band kar dega. But virtual machine monitor will queue up all the subsequent interrupts. ठीक है, जैसे guest enable करेगा interrupt को, all the interrupts which VMM received for that guest operating system, it will give it to the guest operating system. Deliver queued interrupts, right? Now, you may ask, sir, there are interrupts. but there are multiple operating systems. How virtual machine monitor will keep कि interrupt किस virtual machine के लिए आया है? Can anybody give a solution? I have 5 virtual machines. I have 5 types of interrupts. Every virtual machine can receive all 5 types of interrupts. Now user is pressing interrupts. For which VM those interrupts are? How would virtual machine monitor be knowing this? किसके लिए आया है कैसे पता चलेगा?
सर सबको कुछ ऑफसेट दे सकते हैं?
No, because when you apply interrupts, if you have run virtual machines, you would be knowing. You run virtual machine, you are giving some inputs to that virtual machine. It means you are taking that virtual machine on focus. तुम उस पर क्लिक करते हो, माउस से उसमें चले जाते हो, तो सारे इंटरप्ट किसके लिए हैं? उसी वर्चुअल मशीन. Yes. So it is about focusing or choosing a VM. So user itself designates that I am sending interrupts to which VM. And VMM can keep track of 5 different interrupt sets. जिस भी VM का आया है उसमें डाल दो, और जब VM चले तो उसको बता दो कि तुम्हारे लिए आए हैं. Would it work? It is similar to the POPF implementation I told you. Yes, 5 copies of the same data structure. Similarly, 5 copies of the interrupt, vector. Let me give you a diagram. Sorry. Suppose this is VMM, this is user, this is VM1 and this is VM2. Okay, this VMM has 2 vectors, one here, as data structures, and suppose this has 5 values, 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 5 types of interrupts are possible. User is saying I'm sending interrupts on VM1 because VM1 it has kept on focus by doing a mouse over or by clicking on that VM. And suppose I have a class. Okay. So I'll just take 2 minutes to explain this, then you can leave. Okay. Why you need to leave before 15 minutes? There are 13 minutes more, right? VM1, user is sending an interrupt of this type, interrupt type 5. So this was 0, it will be made 1. And user also sends an interrupt as interrupt 2 to VM2. These are known as bit vectors. बाकी जगह value क्या होगी? 0. जहाँ कोई interrupt नहीं आया है. Otherwise it will be 1. Suppose this VM2 sees its vector. कि भी मेरे कुछ आया है क्या? तो VMM will tell, yes, you got interrupt type 2. Do whatever you want to do with it. Interrupt type 2. And then VM2 can respond. And this works nicely. Whatever number of types of interrupts are there, you just need to make bit vectors. Bit vectors are quite, cheap. You need to spend a single bit on every interrupt. Yes. Okay. So Kirtan, you want me to stop or you want me to continue for 5 more minutes?
Sir, I think if it's not going to be a problem, like if it breaks the continuity, then you can
No,
continue.
it's all right.
with the-
It's all right. We can have it in the next class. I hope you could understand whatever we have done today. Yeah.
Yes, sir.
Okay. Anybody has any question, feedback? Please go ahead. Right. It is still 2:20, 2:19 only. Okay, in case there is no feedback,
It's not-
please read both the papers and let us meet in the next expert talk, right? So yeah, thank you, Tanmay.
Thank you, sir. It was amazing. I have shared the paper, this one as well, about
Yes.
the
And each one of you should install a virtual machine monitor, whatever you like, right? And start working with that, because hands-on will only make you a real engineer. Okay. So with this, I'll stop because you have a next class. Thank you. Bye-bye.
Thank you, sir.